All right, so I wanted to jump in and take a look at this problem set that you guys were supposed to do in class, and I'm not sure what's going on, but I wanted to make sure that I wasn't dropping the ball and making sure that you guys had some help on this stuff because we're working in class, but I don't know if a lot's getting done. So we have a bus right here, and of course it's moving at 2 meters per second. Wow, that's almost a not bad drawing. And of course, if we were to magnify this bus, what we'd see is a person on board zipping forward at 4 meters per second. So most of our vector problems have involved like a vehicle or a current, and then some kind of car or boat or something, and then we have this resultant vector like this. This is actually a simpler version. What we have here is basically the bus, and then we have the person walking. And so when we actually do this problem to solve it, what we get is that v bus plus v person is what the person from the sidewalk sees. And so what they see is a velocity of 6 meters per second. Now, here is actually an interesting proposition, which is we're now walking in the previous problem and we drop our phone. And the question is, in the horizontal direction, what's the horizontal speed of that cell phone? So to actually kind of figure that out, let's actually look at a video that sort of explains how this works.
Hi. Oh, I just got back from that convention. Guess what? I saw my patient again. The one-legged one. Yeah. And guess what? She had a hypothermic shock. Yeah. She'd eaten a pretzel, wanted to go swimming. Yeah. And you'll never guess what happened. Oh, I'm stuck. Ouch, I'm stuck.
So clearly, that example actually illustrates something. So if you notice, the car's moving, and the person's moving with the car, and they drop the phone, and the phone falls in the car. It doesn't zoom back and land on the ground. So what that means is that the bus is moving and you're walking, and then you just drop your cell phone. It's going to be dropped, and it's going to have a horizontal speed of 6 meters per second. Excellent. All right, so in this third problem, we actually have a situation of a person walks down 250 meters and then they turn right. I actually had to stop the video and figure out that's how that works out. And then 60 meters to the right like that. We want to know the magnitude of the displacement, and a lot of you tried, actually not a lot of you, I was kind of proud. The most common misconception that people make is this, 250 plus 60. That's wrong. It's completely wrong. We're using Pythagoras' theorem here. So we're actually going from here to here. And so to get that displacement, that's going to be 250 squared plus 60 squared. And so you're going to need to actually go ahead and work that out. In fact, that'll be the Google Docs problem. So this will be Google Doc number 1. And actually letter B will be for you to calculate this angle right here using the inverse tangent function, which you should have learned from the quiz. So I'll want you to go ahead and actually calculate that. Now, and be careful because you've got to rotate your triangle. So again, if this is the hypotenuse, this would be the opposite, and this would be the adjacent. So be very careful when you do that with your triangle to get the angle. So that will be Google Doc question number 2. This is so great. I never thought of doing homework this way with you guys. It just forces you to do everything. I love this. All right, so now we have a delivery truck that moves 25 blocks north and 25 blocks east. So based on your answer to number 3, go ahead to Google Docs, and you will do Google Doc number 3 based on the answer to this here. So this is just wonderful. So I'm expecting you to be able to do that. Now, moving along, the truck now moves back 26 blocks south. So actually, this one will actually work out because it's a little tricky. You go 25 meters north and 25 east, and then of course you go 26 meters south. And so what happens is you start here, and you go down like that. So when you actually, you know what, I don't like that color. Let me do it like this. So I'll start again. So go up like this, over like this. So 25, 25, and then we go down 26. So when we actually get the displacement, we go from here all the way down to here. So if we actually look at this, if we were to take this vector, that would be 25 over like that, and down 1. So to get the magnitude and the direction, you would actually have to calculate this angle here, and you'd need to get this displacement right here. So I'm going to leave that as an exercise to you, so you want to go ahead and do that. And that will actually be Google Doc number 4. Very exciting. Here we go. So now we have a car driving up an incline with velocity 25 meters per second. What are the x and y components of the car's velocity? No way am I doing that one, not after all the stuff that we've been doing in class. So that'll be Google Doc number 5, and you'll actually answer that. Boy, this is exciting. I never realized that this would be a great way to make sure that you're accountable in class. See, so if you actually come to class and you do the work, then homework will take you a very short period of time. But if you don't do the work in class and you have to do it at home and there's homework and it's just terrible and life just becomes a challenge and oh, why didn't I do my homework and oh, this is awful. So yes, so that's how we'll do this. Now here, this west, north, and you know what? I do want to say something about the x and y components. I just want to be clear. If you have a vector v here, the x component is this part, and the y component is that part, assuming you've got an angle theta. So don't let that word component fool you. So don't use that as an excuse to not do Google Doc number 5. That means you're going to actually have to do A and B here. So that'll be Google Doc number 6 and Google Doc number 7. Well, this is great. Wow. Now, how far west will the plane be after 3 hours? That'll actually be, you know what, actually, I don't want to completely mess you guys up on this. So, this Google Doc, we'll actually change this. This will be Google Doc number 6. And what we'll do is we'll actually make this be Google Doc number 7. What I want you to do is calculate this just for practice and realize that if we're going north, well, north is the y component. So what we're going to do is we're going to take this Vy from here and multiply it by the time to get the y that you actually travel. And similarly here, I'll let you figure that out. So if you were to actually do that, I'll actually do one of these for you. So if I were to get the y component, Vy is going to be 755 times the sine of 46.5. And we go ahead and calculate that. We will actually get 547.66 kilometers per hour. And so when we want to get the y, again, this is using the Buggy Lab formula, 547.66 times 3 hours, and that actually gives us the amount that we travel, and that will work out to 1,643 kilometers. So you'll actually do that as Google Doc number 7. That's very good. So really for Google Doc number 6, what you're going to do is you're going to get Vx for me, and that's just going to be great. So now, we have for number 7, this is really quite a tricky one, and let's actually just try to figure this out. So first, we've got a bird, and it goes due east at 7.58 meters per second. And then we have this wind that blows northwest, and I'm just going to write this as 4.18, and it actually goes northwest at an angle of 55 degrees. Now, I'm not entirely sure because when it says northwest at an angle of 55 degrees, we're going to make an assumption here, and I'm going to check this with the other physics teachers. I'm going to say this is 55 degrees. Okay. I'm not completely sure I have that right, but I am going to go ahead and do that. So what we want to know is what are the x and y components of the bird's velocity relative to the air. This is a very interesting question, and I'm not sure why it was given this way, because it seems to me that this is actually quite a complicated question. If I understand this right, we have to treat this as an axis and then go perpendicular to it and find the component of the vector in those directions, and that just doesn't make any sense to me. So I'm going to actually double check this one with Mr. Hermana, because I'm not quite sure what he wanted to say with this one. So we're going to skip this one for now, but do not cross it out. We will come back to it, and this is something that we're going to work out in class together, so this should be pretty interesting. Anyway, we will then talk again and figure this out. So we'll see what's going on.